Okay, good day. My name is Stephen Harrison, and I am presenting the paper titled Exploring an Optimization Strategy at the Maintenance Department of an Oil Company. My co-authors are Mr. Jainarayan Bansi, Mr. Rajiv C. Prasad, Mr. Dylan Frederick, and Professor Bapana Chaudhry. Now, this paper discusses a lean approach to the pump maintenance operations of an oil company within the Caribbean region. In this company, pump repair and maintenance was performed internally by personnel assigned to a subsection of the maintenance department referred to in text as the pump shop. The company sought to maintain capital discipline with a focus placed on productivity improvements, and it pursued an approach to maintenance practices that improved efficiency and productivity, such as adopting a lean approach to maintenance and the reduction of overtime related to maintenance-related activities. This case study, as presented, investigated the proposed lean measures using discrete event simulation. The program used in this case was arena simulation. Now, subject experts were consulted during the process of modeling the system under investigation. And this process involved value stream mapping, collecting performance data, defining the current state of the actual system, determining the desired precision of performance metrics, constructing a simulation model of the existing system, and verifying the simulation using structured walkthroughs and the analysis of the intermediate results of the system under control conditions. We then validated the simulation with assistance of system experts by comparing the simulated performance metrics to that produced by the actual system. And then we proposed solutions were conceptualized, and a model employing those solutions was generated. The performance metrics of the existing and proposed systems were then compared using statistical methods. Now, this is a process map. In the most basic form, field pumps would enter the pump shop with a work order, associated work order. They would undergo a process of diagnosis and disassembly before being repaired, reassembled, and tested. And then they would leave the pump shop with the completed work order. Parts and materials required for the repair process would be requested of the stores department and delivered to the pump shop with a delivery note that was used to track the movement of parts and materials throughout the company. A purchase request, in case the stores department did not have the required parts and materials, a purchase request was sent to the procurement department, which would then send a purchase order to the supplier, who would return the delivery details to the company. The procured parts and materials would be received by the shipping and receiving department, which would send them on through the stores department to the pump shop. Now, these are some of the processes and the statistical distributions associated with them that was based off of the best fit to the collected data. This was used in the simulation that in the existing and proposed models. Now, the following assumptions and limitations were applied to the existing proposed models created. All materials entering the machine shop for any particular pump were treated as one job. Parts were categorized as either good or bad, functional or non-functional. Variations in the type of parts and materials were not considered. The distance traveled by the parts removed from the assembly area was not considered. The variation in the type and model of pumps entering the system was not considered, and suppliers were assumed to provide reliable service of an acceptable standard to the company. Now, this is an extract of from the model showing the pump repair processes. First is a create module, which represented the frequency of the arrival of field pumps into the pump repair shop. The second module is a assign module, which is used by the simulation to assign a unique identifier to the representative entities. This was used to track them as they flowed through the processes of the model. Number 3 is a separate module, and this was used to represent the separation of functional and non-functional parts within the pumps. Number 4 is a route module, and this module is something used by the simulation to transfer representative entities to different areas of the model without passing through intervening processes. In this case, number 4 is a route module representing the movement of a request for parts materials moving from the pump shop to the stores department. Number 5 is a station module, and this was used to represent the arrival of materials, in this case, arrival materials from the stores department to the machine shop. Number 6 is a match module, and this was used to represent the matching of the functional parts of the pump being repaired, being matched with the replacement parts. Number 7 is a process module, which in this case represented the process of repair, reassembly, and testing. And number 8 is a dispose module, which is where representative entities left the simulation, and it reflected in reflecting the repaired pumps leaving the pump shop. As for proposed measures, these measures included the automation of data storage and retrieval through integrating maintenance procedures into the company's enterprise resource planning system, and using tools and devices to automate the process of data entry. Predictive maintenance by trained personnel using information provided by condition monitoring devices, and through the analysis of historical data to track part degradation, and plan maintenance activities with minimal interruption to operations was also a measure considered. The use of the automation of data storage and retrieval was modeled as a reduction in the time spent on data entry tasks. And the effect of predictive maintenance was modeled by having entities first enter the model as a part of material request. This represented the use of historical or condition monitoring data to predict the likely occurrence of part failure mode, and this would then allow for parts materials to be secured prior to initiation of the actual pump repair process. And, excuse me, yes. And these are some extracts from the proposed model showing here where at number 1 in the illustration to the left. This is where the entities first entered the simulation, and they would undergo the processes of the stores department before pumps would enter the pump shop. And this allowed for waiting time associated with waiting for parts materials to be procured, to be eliminated from the process. Right? This would all take place while the pump was still online. And then once these preparations had been taken care of, the pump would be taken offline, and sent to the pump shop. These are performance metrics of the existing and proposed model. We found the average wait time decreased by 96%, average flow time decreased by 76%, and with independent samples t-test, we found that this decrease in wait time and flow time between the proposed and existing models was a statistically significant difference at a 95% confidence interval. No significant difference was determined for working process, however. Now, these are some of my references. Thank you. Any questions?
Okay, thank you very much, Stefan. I see we have very distinguished people on the co-authors list there, but I'm sure that you'll be able to handle the questions. The first question, and the most obvious one, is that from your current state map to your, I guess, your future state map, what were the cost savings rate?
So in terms of the cost savings, we looked at it in terms of how you save on time. And in this case, the time related to the maintenance activities was decreased by 96% in terms of waiting for materials. So this was time where the pumps would still be online while you procured the materials required for repairs, and they would only be taken offline when the setup for the repair process was ready. So in terms of the financial savings, you will only be ceasing actual production when it was absolutely necessary, and you'll be trying as best as possible to minimize time wasted on waiting and so on.
Okay, good. Thank you. Also, when you did your analysis of on the process of collecting the data, a value stream manager does it. How long did it take for you to collect all the data?
So the data that we collected, we used the SAP system, which of the company, which tracked things like when pumps were taken into the shop and how long it took for repairs and things like that. So we actually had a wealth of data that was available for going back at least 3 years.
Right, thank you. And how receptive was the staff to changes to take your suggested improvements?
So in terms of the staff, well, these suggestions were beneficial in terms that it reduced the efforts required while increasing effectivity, and it was an approach that that depended more on training of staff. So the barriers to these suggestions went from the staff themselves, but from in terms of management, in terms of procuring the required training and implementation.
Okay, one other comment we have here, a very good presentation. Can your model be incorporated in conventional computerized maintenance management systems, such as CMMS?
Yes, this is actually very compatible with CMMS, and they actually do exist existing systems that do apply this condition monitoring and so on with CMMS to automate the process of planning for these maintenance procedures. The main barrier as it exists currently is that this requires expertise and training of the staff to properly apply and analyze the condition monitoring data, and to look at the historical data and the signs of part degradation to understand it. So in terms of automating that facet of it, it requires a lot of data specific to the process itself before you can effectively use that.
Okay, thank you very much, Stefan, for a very good presentation, very informative.
Thank you,
we are, yeah, Sanjay, you want to?
No, that's really good. Thanks, Stefan, and we appreciated that. Very informative.
Okay, thank you.